All right, welcome to Chapter 1, Section 1. Here we're going to really get into a core foundational piece of trigonometry, and that is to talk to you about angles. And you're probably familiar with angles. We have some definitions here on this page that you can read through. If I go down here to where they start talking about angles, as you probably recall from other classes, an angle is formed between what they're going to say two rays that share a common point or vertex. And so as I look at this angle right here, this they'll probably call something like the angle theta, usually using a Greek letter to denote angles. And angles are always measured in a counterclockwise manner. So if a positive angle would move counterclockwise, a negative angle will move clockwise. And you'll have lots of practice with that in this first section and others to come. And so what I just talked about is actually written here. Counterclockwise rotation results in a positive measure. Clockwise results in a negative. But it's important to know that a degree is kind of arbitrarily set to be 1/360th of a full rotation. I think we all walk into this class knowing that 360 degrees is a full rotation. 180 degrees would be a half rotation. We have some of these ideas in mind. So as we come down here, we have some terminology that they're going to use. An acute angle is an angle that is less than 90 degrees. A right angle is exactly 90 degrees. You're probably very familiar with that with your work at the Pythagorean theorem and others. An obtuse angle is more than 90 degrees. And a straight angle is one that's straight across. That's exactly 180 degrees. It would look like a flat line if we were to look at a terminal side like that. So, for example, if I came up here and did the same red line for the initial side and did a blue line for the terminal side, that measurement right there, 180 degrees, is what makes us flat and straight, and that's where it gets its name. They're also going to remind you about some terminology, and maybe it's not a reminder, maybe it's the first time you're hearing this. Complementary angles are angles that add up to be 90 degrees. We call those complementary. We call them supplementary if they add up to be a straight angle of 180 degrees. The way I remember who adds up to 90 and who adds up to 180 is by remembering that complementary and supplementary are alphabetical. So complementary comes first, that's the 90-degree one. Supplementary comes second, that's the higher one, or 180 degrees. So in example 1, you have an example of something that you'll see in the homework. And what they have are two complementary angles, A and B. And so we can see by the picture that A plus B is equal to 90 degrees. And so we just need to solve that. 4x plus 12 is what A is. B is 2x plus 66, and that needs to be equal to 90. And then it's just simple algebra from here. 6x plus 78 is equal to 90. Move over that 78 to get a 12, and we get a nice x equals 2. Now, we're not done. The question, if you look at the question, it says find the measures of the marked angles. We haven't found any angle. We just found out that an x value of 2 will help us discover those. So don't forget to finish problems. And so the angle A is going to be 4 times 2 plus 12, or 8 plus 12 for 20 degrees. Now you can go ahead and label B as 70 degrees because you know it's got to be up to 90, or you can use and substitute in to double check that the 2 that you found is right. But it is. 4 plus 66 is the 70 degrees that we were expecting, so a nice little double check there. As we go into other examples that you'll find as you go through the homework, we have some clock measurements. And if you remember a clock is separated into 12 equal segments. And so because it's separated into 12 equal segments, we know that there is 360 degrees in a full rotation, and each one of those 12 marks, so if I divide that by 12, is going to be 30 degrees. So in between 12 and 1 is a 30-degree angle. 1 and 2, a 30-degree angle. Hopefully you can see that. Now what they're asking for us to do is, for example A, 4 o'clock. So one hand would go up to the 12, the other would go to the 4. So what angle measurement is that? Pretty easy. From 12 to 1, that's 30 degrees. From 1 to 2, that's another 30. From 2 to 3, another 30. And 3 to 4, another 30. We have 30 degrees added up 4 times, or 120 degrees between those two clock hands. If we look at something a little bit more complicated like 130, let's remember here's 12, here's 1, 2, 3, 4, 5, and 6. 130 would have the hour hand right in between 1 and 2, exactly halfway in between, because we're half past, and then a line straight down to 6. So there is a 30-degree measurement between 6 and 5, a 30-degree between 5 and 4, a 30-degree between 4 and 3, a 30-degree between 3 and 2. But between 2 and 1, we don't actually have the full 30 degrees because it's halfway in between. We have 15 degrees more. So that's 30, 60, 90, 120, 135 degrees is that middle one there. Now, 145, how do we would do that? Well, pretty much the same way. But we got to be really careful. Here's 12. Here's 1, here's 2, and so the hour hand will be right there. If you remember, 9's right over here, that's the 45 mark. And the angle that they want is always the closest angle in between them. And so, yeah, because it says here, find the smaller angle formed by the hands. So they don't want this outside one, they want this inside one. Well, from 9 to 10 is 30 degrees, 10 to 11 is 30 degrees, 11 to 12 is 30 degrees, and 12 to 1 is 30 degrees. So what is that? That's 1, 2, 3, 4 of these 30-degree measurements for 120. Well, that brings me up to the 1, and now I got to move 3/4 of the way through that interval, right? Because that's where 45 is. It's 3/4 of a way through that interval. Well, 3/4 of 30 degrees. Well, 4 will go into 30, well, it won't, so let's just be careful here. 15 times 3 is 45, divided by 2, well, that's 22.5 degrees. Put together with 120, well, that's 142.5 degrees. And so you're going to creatively think about what to do. That's actually a really good math concept that transcends just this. And so they're going to take this idea of angles and they're going to make sure that we can use our thinking skills and our critical thinking skills to come up with information and answers given certain information. Now, it's rare, but it is true that degrees are measured in degrees, minutes, and seconds. And so a minute is 1/60th of a degree, and a second is 1/60th of a minute. And so we got some definitions there. And so you'll see this, I think it says in the notes where we give latitude and longitude, we'll deal with this stuff. But we want you to be able to critically think your way through this. So here we are, and we have this degree, minute, seconds. And what we need to remember is 60 seconds makes a minute, and 60 minutes makes a degree. Well, what we're going to do first is just add 31 and 59. So I'm looking here at example 3. It's related to problem number 48 in the book. And we're going to look at 31 plus 59. If we look at 31 plus 59, we are going to get 90 seconds. And if I look at 42 plus 32, I'm going to get 74 minutes. And if I look at 50 plus 21, I'll get 71 degrees. Now, that's true, but it's not the right answer because we should be looking at the fact that there's 90 seconds. Well, there's 60 seconds in every minute. So I'm going to take away 60 of these and add 1 minute to the 74. And what am I going to be left with here? I'm going to be left with 30 seconds. So in my final answer, I'm going to have 30 seconds. Now, what I have here is 75 minutes, but I'm going to take away 60 of those to form 1 degree. So taking away 60 is 15 minutes. And then I have 72 degrees. And so my answer is 72 degrees, 15 minutes, 30 seconds. It's 100% the same as carrying over as you do with a regular arithmetic. So the seconds was way overloaded at 90. So we pulled a minute away and put it to the next minute category and found out the remainder of the seconds. If we have something like B, what we have is 90 degrees. Well, 90 degrees minus this is going to be a little bit of a problem because I don't have any minutes or seconds to deal with. So it's almost like having 9,000 minus 1,282. I got a little bit of a problem because I can't subtract 2 from nothing, so I got to borrow. So, and remember what we do when we borrow. We bring it to the next one, borrow from there, bring it to the next one, borrow from there, bring it to the next one. That's exactly what we're going to do here. We're going to have to borrow from the 90. We have to make that 89 degrees. And so I have this 1 degree that's left over. Well, that 1 degree is 60 minutes. So now I have 89 degrees, 60 minutes. Well, that's a problem because I still need to get down to the second. So I have to borrow from the 60 minutes and make that 59 minutes. And then what I have is 60 seconds. And so I'm going to change this to a 59 and a 60 seconds, and then everything should work out great. We're going to first take the 60 seconds minus 47 seconds. And you're welcome to use a calculator as you go through and do this. I'm going to take the 59 minutes minus the 18 minutes and come up with 41 minutes. And then I'm going to take the 89 degrees and subtract away the 36 degrees and come up with 53 degrees. And that red answer is our final answer. So we just want you to get familiar with playing around with those. In this next one, they want us to convert the angle measure to degrees. If applicable, round to the nearest thousandths of a degree. And so what we have is, let me switch back to the blue. We have 165 degrees and we have 51 minutes. But 51 minutes is really 51/60th of a degree, because for every minute, well, each minute is 1/60th of a second. And if that's the case, then the 9 seconds that are out here, I want to relate everything to degrees, is going to be divided by 3,600. Because the 9 seconds, 60 of them make a minute, and 60 of those make a degree. So we're going all the way out to degrees. That's the best way I can approach this. And we're just going to plug this all into our calculator. It's the 165 plus 51 divided by 60 plus 9 divided by 3,600. And when I look at that, I get 165 point, and that shouldn't be surprising, 8525. And it did ask me to round to the nearest thousandths, so that's 165.853. And don't forget to put your degree symbol on there. Without the degree symbol, you've used another unit of angle measurement, and it would be wrong. And so we got to be careful of that. So make sure there's that little circle there. Finally, for this page, we have convert an angle measure to degrees, minutes, and seconds. Round the answer to the nearest second if applicable. So what we're going to realize is that we have 122 degrees for sure. And then we're adding to that 0.6853 of a degree. And so we're going to multiply that by 60 minutes and see what we get. We get 122 degrees plus 41.118 minutes. So now we have 122 degrees plus 41 straight out minutes plus 0.118 of a minute, but a minute is 60 seconds. And we just kind of keep this rolling effect going on. It's has some other applications, so it's really nice. I did something that was a little bit confusing. I have an extra 0 in there. I don't know why. I just looked back and saw that. So it should 122 degrees should have just went along for the ride. Now if I look at 60 times the 0.118, I get 7.08. And so they're going to do 122 degrees, 41 minutes, and that's 7 seconds. They'll usually leave off the 0.08 But this result right here was 7.08. I never showed that, but it was 7.08 seconds. So I think that's what they'll have in the back. If they have the 0.08, make note of that and then do it that way. It should be good. Let me get rid of this line here. I think this is the last page here. An angle in standard position if its vertex is at the origin and its initial side is on the x-axis. And so if I draw that, I'll use a black pen to draw a set of coordinate axes, and then I'll use the same red that they did earlier for the initial side. So we're talking about an angle in standard position if its initial side is on the x-axis. So an angle could be, let's suppose this is its terminal side. This is an angle theta in standard position, right, where that initial side is on the x-axis. Angles in standard position where the terminal sides lie on the x-axis, y-axis are called, like 90 degrees, 180 degrees, 270 degrees, and so on, are called quadrantal angles. Angles with the same initial and terminal sides but different amounts of rotation are called coterminal angles. Their measures differ by a multiple of 360 degrees. Okay, all of that's true. So if we take a look at what was said there, let's take a look at an angle. Maybe an angle in standard position looks like this. And let me just say that that's something like 30 degrees. So 30 degrees would be the measurement of that. If I were to do a full rotation around and look at 360 degrees and 30 degrees more, 390 degrees would be coterminal. You would not be able to tell a difference between those two angles because of the circular nature of them. And so as we go to this page, they want to say, give an expression that generates all angles that are coterminal with 225, and n's going to represent the integers. Well, what they're trying to say is, if you take 225 and add 360 degrees however many times you want, you're going to end right back up at the exact same place. When you have example 7, it's really important that we find some coterminal angles. You often want to find the one with least positive measure, like they're doing here. But sometimes we just want to make sure we understand a concept. So they want us to find the angle with least positive measure coterminal with each of the following angles. So 260 degrees would be an angle right back here. This line right here, the one that's down, the straight down y-axis, apologize, is 270. So 260 actually is a little bit closer there, but it's here in that quadrant. You don't necessarily need to draw it, but I need to get something that's coterminal with that. No problem. 260 degrees plus 360 degrees will give me the answer. And so 620 degrees is the angle of least positive measure. Notice if I subtract off 360, I go negative. That will be a coterminal angle, but it won't be a positive measure. And so I want the smallest one. With negative 750, remember what that's doing. That's going backwards. That's going in the clockwise direction, right? And it's actually going more than 2 rotations. That's why I drew it like that. 360 would be one rotation. 720 would be another. So if you want to find the measure of least positive, the least positive measure coterminal with that, well, just start adding 360. We know we're not going to get it the first time, but take your negative 750, add 360, and we're still negative. We're at negative 390. Add 360 again. We're at negative 30. And then we're going to add 360 again. And we're going to get 330. So we kept adding 360 because we weren't positive. All these angles are coterminal. So 390 degrees negative is coterminal. Negative 30 degrees is coterminal. 330 degrees is the one of least positive measure. So here in example 8, we want to locate the point negative root 2 over 2 and 2 root 2 and draw a ray from the origin to that point. So negative 2 root 2, if we look at that, that's going to be in this third quadrant. So we're going to go 2 root 2. Let's just see what that comes out to on our calculator. If you do 2 times root 2, yeah, it's coming out to be 2.8. So it's almost 3 away. So 1, 2, 3. And then up the same amount. So it's right about there. And this is our guy right here. So I don't know what they want. They want us to find the distance r from the origin to that point using the distance formula. Okay, so the distance formula says this, that the distance between the origin, which I'll call r, and a point is simply this, the square root of x squared plus y squared. So how does that come to be? Let me draw this bigger, and let me just pick any xy. So let's suppose this is the point xy. Notice then that if I drop the perpendicular down to the x-axis, that we would have this distance be x and this distance be y. If we want r, it's just the Pythagorean theorem because this is a right angle. That's where the distance formula comes from. And so what do we have to do? We have to take the negative 2 root 2 and square it, and then we have to add to that 2 root 2 squared. If you square 2 root 2, you're going to get 8. And you'll get 8 here. And so we got the square root of 16. So the distance out from the origin to that point is simply 4. Okay, and that will be interesting as we move on. So as we look at the homework, you're going to have some word problems at the end. And so this is an example of one. An airplane propeller rotates 1,000 times every minute. Find the number of degrees that a point on the edge of the propeller will rotate in 1 second. And so we have to be careful with the units that they're talking about here. So it's going to rotate 1,000 times per minute. And so we need to find out how much it's going to rotate in a second. So that's how I would handle it. It's going to rotate 1,000 times every minute, but I don't care about that. I want to know how much it's going to represent in seconds. So 60 seconds there. So if I take 1,000 and divide by 60, I'm going to get 16 and 2/3 of a rotation. So it's going to rotate 16 and 2/3 times every second. Well, we know what a rotation is, and that's the question is what degrees will it rotate every second? Well, it's going to rotate 16 full turns and 2/3 more. That's 16 360s and 2/3 more. So we're just going to take that times 360 and see what happens there. So we got 16 and 2/3 times 360, and if we do that, we'll come out really quickly that it rotates 6,000 times. Oh, apologize. It's rotating 16.3 times, right? Full rotations throughout there. It's rotating 6,000 degrees, right? As that happens, 360, 360, 360, and you keep adding 360 16 times. That gets you close to 6,000. 2/3 more will get you exactly to 6,000. Okay, and so that's our 1.1 discussion. Hopefully that makes sense. Here we go.